So today we will see a small topic in physics that is Ohm's law. So before getting into the law, I'll ask you a question. Have you ever wondered why when we use a higher voltage battery, the bulb will glow brighter? When we use a low voltage battery, the bulb will be dimmer. So from this, we can analyze that there is some relation between voltage and current. So the relation between voltage and current and how it is controlled, it is all given by a gentle scientist called George Siemens Ohm. So what is electric current? Electric current is nothing but flow of charges. So current is flow of charges. So for something to flow, we need some external push, right? So when we want to push an object like a box, we want to apply some external force. So in the same way here, what is flowing? Electrons are flowing. So for electrons to flow, we need external push. Who is giving that push? The external push is given by voltage. So voltage increases, current increases. When you like take the analogy of a box, when you want to apply, move a box very fastly, you have to apply large force. In the same way, when you want to make the electron to move fast, you have to apply the required amount of voltage. So voltage is proportional to current. So this is the basic initial idea of George Siemens Ohm. So what he is telling? Voltage is proportional to I, means the amount of electron flow is proportional to the amount of voltage that we supply from external source. Next, so we will try to understand the complete law using an analogy and using a picture. So we all are familiar with the water tank, right? In all our household we have water tanks, right? Where you see water tanks, mostly water tanks will be seen in the terrace. Mostly it will be in the top floor. Why? Because to maintain the pressure. When the pressure is high, the water will flow very easily. Take that same analogy and apply here. Here also, like similar to water flow, electrons are flowing. So for electron flow, the same external push should be there, right? Who is giving that push? That is given by the potential voltage, external voltage source. So as water flows from higher pressure to lower pressure, in the same way, in an electrical circuit, electrons will also flow from higher voltage to lower voltage. Okay, this is what the basic idea of Ohm. Now, won't it like take the same analogy of a water flowing in a pipe. Won't it depend on the type of pipe we use? So if the pipe is arrested or if the pipe is narrow, the flow of water will be distracted and the flow will be less, right? In the same way, the type of material, the wire we use also matters for the current to flow. So George Siemens Ohm later understood that the current flow depends on voltage and also depends on the type of material we use. Okay. So what is Ohm's law? We said V was proportional to I. It was his initial idea. It doesn't depend, the current flow doesn't only depend on the external voltage source, it also depends on the type of material. So who is giving, what quantity is giving this material property and all means resistance. So the law is as follows. V is equal to IR. So the current flow is proportional to the external voltage applied. It also depends on the type of material we use. The material property is given by resistance. Okay. So in physics we usually we deal with many physical quantities, right? So when we measure, if we want to measure a physical quantity, we always want to define units of that quantity. So everything is a physical quantity. Voltage is a physical quantity, current is a physical quantity, and R is a physical quantity. So for all these physical quantities, we should try to give units of each of the quantity. So first let's see the unit of voltage. Voltage units is volt. We call the unit of voltage as volt. How current is measured? The unit of current is ampere. Next, resistance. The unit of resistance is ohm. So this is how the law is defined. Now I said the current flow proportional to voltage and it also depends on the type of material. Okay, now how it depends on the type of material? The material dependency is given by resistance. Now we are going to see how resistance depends on the type of material. So here we saw V is equal to IR. So material dependency of the material is given by resistance, R resistance. The formula for resistance is R is equal to rho L by A. Okay, what rho L by A, we will see why the formula is like this also we will see. So resistance proportional to length. What is basically resistance means it opposes the amount of opposition offered for the flow of electrons. So how it depends on the material. So let's take a material, let's take a steel, okay, steel rod. So it depends on what type of material we use and the geometry of the material. So steel, we all know that steel is a conductor and wood is an insulator. We can't flow current through a wood, but whereas we can flow current through a material called conductors. Example, steel, iron, copper, anything like that. So what type of material, it can be said by the quantity called resistivity. Rho is called resistivity. And the amount of opposition offered for the flow of electrons depends on the length. See, you can see here, length is directly proportional to the opposition. Why it is directly proportional? Let's see here. We said that electron flow is called current. Let's imagine a wire. This is a magnified image of a wire and here electrons are flowing, which means current are flowing. So when the length is higher, the electrons will collide more and it will offer more resistance for the flow of electrons, which means automatically the current will be getting reduced. So this is because of this only resistance is directly proportional to length. Now why it is inversely proportional to area? Let's see this. I will take two scenarios. This is wire 1 and this is wire 2. Here initially 3 electrons are there and here also 3 electrons are there. So can you guess and tell whether the collision among electrons in this case 1 or case 2 will be more? It is obvious, right? In the case 2 only more collision will be there. Why? The area is very less, so electrons will collide among themselves more. So when electron concentrate on collision between them, will they flow easily? No, because they will be keep on concentrating on collision among themselves and the flow will be getting reduced. So this is how when the area is more, the resistance will be less. Why resistance is less? Because the collision will be less and they will be taken forward easily, but whereas in this case the resistance is very high. Why? Because here the electrons will be colliding more among themselves itself first, so they will be concentrating for collision and they won't move forward easily. That is why the resistance is inversely proportional to area. What it tells means if the area increases, resistance will be low. If the area decreases, resistance will be high. The main reason behind this is collision. Okay, so we saw why resistance proportional to length and inversely proportional to area. Now this resistivity, why it is directly proportional to resistivity? Resistivity is a material specific property, means if wood is there, the resistivity is a fixed value, and if there is another material called steel, the value of a resistivity for that steel will be fixed. So it depends on the material we use. Example, you can directly tell this. So if we use wood, the resistance is very high, which means resistivity is also very high. So this is how the formula of resistance is defined. So L is length and A is area. So what we saw, V is equal to IR. The voltage we supply will be directly proportional to the current that is getting into the circuit. Now what we also observed from the experiments was, it also depends on the material property. So that is given by resistance R. Resistance R, it depends on many factors, the different types of material properties like the geometry of the material and what type of material we use. The geometry dependency is given by length and area, and the type dependence is given by the resistivity. So we'll try to find the unit of resistivity by the previous knowledge. We know the unit of resistance is ohm, right? And we'll take the unit of resistivity as unknown. Okay, let's take it as X. We know the unit of length as meter and the unit of area as meter square. So we can cancel meter and meter square, right? So what will, from this what can we do? We can rearrange, we can take this m to numerator and we can rearrange and find the unit of resistivity. What is the unit of resistivity? Ohm will be there and meter will be there. So what will be the unit, what will be x? X is equal to ohm meter. Hence the resistivity of the SI unit of resistivity is found. So from this we can, like when we know basic quantities, we can try to find SI unit of unknown quantities like resistivity, because resistivity is something we are unfamiliar, right? We know we are familiar with the resistance, we usually read and we know the unit of length, area and all. So this resistivity is something new to us. So we try to find the unit of resistivity from the known quantities like this. Next.